Hi, you guys. Here's your lesson for section 10.6, the volume of prisms and cylinders with Missy McCarthy, Okemos High School math instructor. In this lesson, you're going to learn how to use the formulas for volumes of a prism and solve problems using those formulas, and you're going to learn how to use and apply the formula for volume of a cylinder. All right, so here we're just going to reiterate what we were doing. Surface area is what we were covering in the previous sections, and surface area is just asking the question, how much will cover it? If you're trying to cover something, the area is the surface area. Now we're going to transform our thinking a little bit. Instead of covering it, we're thinking how much will it hold or how much will fill it. So surface area, wrapping, volume, filling. So the volume of a prism is going to be the area of the base. Whenever you see that capital B stands for area of the base, times the height. And as you can see here, if we have rectangular prisms, we just say length times width times height, because the area of the base is length times width, and then the height of the prism. And then we can get even more specialized for a cube, because the length and width and the height are all the same, so it's S times S times S, which is S cubed. So we got our formulas here. In general, the volume equals the area of the base times the height will work for any prism. If you want to get specific, we can choose these two prisms and remember two other formulas. But I would err on the side of just using this formula for everything that we do. Okay, so we're going to find the volume of this prism and round our answer to the nearest tenth if necessary. So as we're looking at this prism, I'm going to try to find the area of the base and multiply by the height. So volume equals area of the base, that's capital B, times the height. So the volume is, the area of the base is 13 times 3, and then times the height of the prism, which is 5. So we do volume equals 13 times 3, which is 39, times 5, and we get 195 square centimeters. Now think about it. If you were to take this prism and you were to stand it up, the bad drawing, but you guys get the point. And then so that made this 5, that made it 13 tall, and that made this 3 centimeters. So now it's standing on this base here, or this base here. Okay. If you were to find the volume of this prism, it should hold the exact same amount. So if we look at it, volume would be the area of the base. In this case, the base would be 5 times 3, and then times the height, which is 13, and you'll see you get 15 times 13, which is also 195 square centimeters. Oh, cubic centimeters. My bad. We're talking about volume. Centimeters times centimeters times centimeters is centimeters cubed. So the prism, it really doesn't matter which way you turn it if it has a rectangular base. If it has a triangular base or hexagonal base, then the bases are evident, and the height is always the side along the lateral edge. Okay, another joke of the day. What 3D figure can cure strep throat? Wait for it. A penicillin. Those of you who are laughing at this right now, I wonder about you. All right, so we got volume of a cylinder here, and the volume of the cylinder is actually the same as the volume of a prism. It's the area of the base times the height. But we oftentimes substitute pi r squared in for the area of the base because the base doesn't change. The cylinder's base is always pi r squared, or it's always a circle. So if you look here, I didn't illustrate this in the last one, but for our volume, we can find the volume of a right cylinder or the volume of an oblique cylinder, just as long as we know the correct height. So we can find the volume of either of those using this formula. So if we look here, it says find the volume of the cylinder, give your answer in terms of pi, and round to the nearest tenth. So I'm just going to leave everything in terms of pi first, and then we'll plug it into the calculator. So if the diameter is 18, that means the radius is 9 inches. And the height is 14 inches. And the volume of a cylinder is pi r squared h. So we have pi times the radius, which is 9 squared, times the height, which is 14, which gives us 81 times 14, which is 1134. So we have 1134 pi, and it is cubic inches because it's inches times inches times inches. So that's the answer in pi. If we multiply times pi, we can say that it is approximately 3,562 round to the nearest tenth, so 0.6 cubic inches. So we just found the volume of that cylinder. All right, now let's find the volume of this cylinder. It has a base area of 111 pi square centimeters and a height equal to twice the radius. So we know that the volume is equal to pi r squared h. And we know that the height is equal to 2 times the radius. Well, we can find the area, we can find the radius because we know that pi r squared is equal to 121 pi. If we divide both sides by pi, we get r squared is equal to 121, and square root both sides, we get r is equal to 11. So if r is 11, then we plug it right back in there, and we get a height of 22. And now that we know the radius is 11 and the height's 22, we can plug those in to find our volume. So volume is going to be equal to pi times 11 squared times, oops, I should probably have a 22 here. So we got 11 squared times 22, and that gives us a volume of exactly 2662 pi cubic centimeters, or approximately, if we multiply times pi, approximately 8,362.9 cubic centimeters. And that's it. That's all you got to do. Okay, so this says the radius and the height of a cylinder are multiplied by 2/3. Describe the effect on the volume. So we've been looking at this over the course of about 3 or 4 sections now. If the dimensions are affected by a factor of A, or multiplied by a factor of A, then we've come to determine that the area, whether it be area of a 2D figure or the surface area of a 3D figure, will be impacted by a factor of A squared. So then what's going to happen to the volume? The volume should be impacted by a factor of A cubed. So this would be dimensions, area, and volume. So let's check and see. Let's find the volume of the original. The volume of the original is pi times 24 squared times 33. So it's 24 squared times 33, and that's going to be 19,008 cubic inches. So that's the original volume. Now, after we multiply both of these by 2/3, so if we multiply 2/3 of the radius, our new radius is 24 divided by 3 is 816. And if we do 2/3 of the height, that's going to be 22 inches for our new height. Now, if we find our new volume, it's going to be pi times 16 squared times 22. So 16 squared times 22, and that gives us 5632 pi cubic inches. So we said if it was affected by a factor of 2/3, then that means the volume should be affected by a factor of 2/3 cubed, which is 8/9. So if we take our original, oh, and I forgot my pi here, didn't I? If we take our original and multiply by 8/9, we should get our new one. So 19,008 times 8 divided by 9, and that gives me, why doesn't that work? Oh gosh, because 3 cubed is not 9, 3 cubed is 27. So if we do 19,008 times 8 divided by 27, we do get our 5632 pi. Okay, so it's the same relationship that we looked at between dimensions and area, just continuing for volume. All right. Make sure you rewatch any parts of the video, come to class with questions tomorrow, and be ready to work hard. See you then. Bye.